Hello everyone, welcome to my channel and welcome to another video on integration. In this video I have a definite integral, one that I would like us to look at. It's the integral from 0 up to 3 of the natural log of 2 times 2 to the power the square root of x plus 1 all over the square root of 4x plus 4 dx. Now looking very intimidating, but you know we use substitution here. As you can see, we have a square in the power of 2 there and a square in the denominator as well. So perhaps the starting point would be to take the natural log of 2 out because it's a constant, and then you can see this one here requires factorization. We'll do the factorization there as well, and then take whatever we can out of the integrand as follows. Taking us to the first page here, page 1. And we are saying we are dealing with the integral of from 0 up to 3 of the natural log of 2 times 2 to the power the square root of x plus 1 all over the square root of 4x plus 4 dx. Step 1, take the natural log of 2 out. So what we have now is the natural log of 2 times the integral from 0 up to 3 of 2 to the power square root of x plus 1 all over. In the denominator, I'm going to have to factorize 4x plus 4 as follows. The common factor is 4. 4 into 4x is x. 4 into 4 is 1 dx. Now notice something. This here is a product of two numbers, and we're taking square root of that. It means we can split the 2 into the square root of 4 times the square root of x plus 1 as follows. Step number 2, the natural log of 2 times the integral from 0 up to 3 of 2 to the power square root of x plus 1 all over square root of 4 times square root of x plus 1. And then we have dx there. And you can see that square root of 4 is actually 2. And we can take 2 out, and it's dividing, remember, so it's half. Taking it out, we have the natural log of 2 divided by 2, because square root of 4 is 2, times the integral from 0 up to 3 of 2 to the power square root of x plus 1 all over square root of x plus 1, and then we have dx. Fantastic. Now at this point, I am going to work on the square root of x plus 1. We're going to let t squared, because we have the square root there, t squared be equal to x plus 1. The first equation is to obtain the positive square root on both sides. The positive square root of t squared is t. The positive square root of the right hand side is just the positive square root of x plus 1. Why is this important? Because we have to change the limits of integration now. So now using this equation here, we can obtain new limits as follows. Taking us to the second page. Right, so this is page 2. Now what I'm saying is we're going to say as x approaches 0, as x approaches 0, what does t approach? T approaches, remember we substitute 0 there now. The square root of 0 plus 1, this is equal to the square root of 1, and the answer is 1. That's our lower limit. And as x approaches, the upper limit there is 3 of x, as you can see. T approaches, we put 3 there. It will be square root of 3 plus 1. This is equal to square root of 4, positive square root of 4, and the answer is 2. So our new limits are lower limit 1 and upper limit 2. So we can change the integral therefore as follows. I'm going to draw an arrow here and say that is equal to this integral here. Let me move this down so you can see what I'm talking about. This integral here changes as follows. We're going to say natural log of 2 over 2, natural log of 2 over 2 times the integral from 1 up to 2 of what? Of this part. Now the numerator is going to be 2 to the power square root of t squared. Remember, t squared equals x plus 1. And we're saying all over square root of t squared times, we need to obtain an expression in terms of dx. That means we have to differentiate this one now. So if you will allow me to insert it here with a different color, maybe a black one. If you allow me to insert it here, we are saying, yeah, I'm going to put it here. So take this equation, which is t squared. T squared is equal to x plus 1. Differentiate both sides. You'll agree with me that we have 2t dt will just be equal to dx. There is the component. Now we take this into the place of dx. Right, so we have now 2t dt there. Fantastic. Now, moving forward, we have to simplify. You'll agree with me that this is equal to the natural log of 2 over 2, and we are saying times the integral from 1 up to 2. This part here, you'll agree with me that this cancels that, and you just have 2 to the power t, 2 to the power t all over. This is just t, obviously. As you can see that the radical cancels with the 2 there, the 2 cancel, and what do we have now? Times 2t dt. Now, these cancel. Take the 2 out, and what do we have? We have natural log of 2 over 2 times 2 times the integral from 1 up to 2 of 2 to the power t dt. Fantastic. Now you can agree with me that these cancel. And what do we have? Taking us to page 3. On page 3, what we have now is the following. So this is page 3. What we have now is that it will be equal to the natural log of 2 times the integral from 1 up to 2 of 2 to the power t dt. Now we can let u be equal to 2 to the power t. Let u be equal to 2 power t. Because we have an exponential function or expression on the right hand side, we're going to use natural log now. The natural log of u will be equal to natural log of 2 to the power t. And applying one of the laws of logs, when you have a power there, the power must multiply. So this is natural log of u. If you have watched some of my previous videos, you will see that I have explained how this changes applying one of the logs of logs. So this is actually 2 t times natural log of 2. The power must multiply. At this point, I'm going to have to differentiate both sides with respect to t. So derivative with respect to t of the natural log of u, this must be equal to derivative with respect to t of t times natural log of 2. And you'll agree with me how we differentiate logs. Remember, we're going to have to reciprocate u. So on the left, we have 1 over u times d. So 1 over u times derivative of u. Remember, du dt. That's how you differentiate logs. This is equal to, take the natural log out because it's a constant, natural log of 2, and derivative of t with respect to t, the answer is just 1. Multiply both sides by u dt. You're going to have on the left du, on the right you're going to have u times natural log of 2 dt. Now notice something here. U, if you go back over here, u is 2 to the power t. So now what do we have? We have du is equal to 2 to the power t natural log of 2 dt. Now we have to divide by natural log of 2 both sides, because over here we have 2 to the power t times dt. So here we have 2 to the power t natural log of 2 dt. So we have to isolate 2 to the power t dt. So we can have that expression there. Taking us to page 4. And hopefully to finish this up as quickly as I can. Taking us to page 4. So what do we have now? So what we have is the following. So we have du all over natural log of 2 And the answer is going to be 2 to the power t dt. Fantastic. Now, if you check this expression here, we clean up a little bit. If you check that expression, 2 to the power t dt is actually what we have here, 2 to the power t dt. And then we have natural log of 2 outside, but the limits are 1 to 2 with respect to t. So we have to change the limits of integration now. So changing the limits of integration, which equation do we need? We need this equation here, u equals t 2 power t. So let me bring it here, u equals 2 power t. And we're going to say as t approaches 1, remember the lower limit is 1. What does u approach? U approaches to the power 1, which is 2. You substitute 1 there. And as t approaches, let me distance this a little bit. I want to space it out from us. And as t approaches, what is the upper limit? Upper limit is 2. You can see here, 2. As t approaches 2, I want to say approaches 2, like that. Remember, these are limits, okay? They're limits of integration. So in terms of limits, you say as something approaches something. So as t approaches 2, u must approach 2 to the power 2. Remember, we put 2 there, and the answer is 4. So now we can transform this integral totally to, allow me to put an arrow here and say the natural log, that will be equal to natural log of 2. Let me just capture the whole integral, 1 up to 2 of 2 to the power t dt. This is equal to natural log of 2, the integral. Remember, lower limit now is 2, upper limit is 4 of what? This expression, as you can see, is equal to that expression. So du all over natural log of 2. That's what we have now. And we just have to simplify this, finish up quickly. Take the natural log of 2 out. Natural log of 2 over natural log of 2 times the integral from 2 up to 4 of du. And you agree with me, these cancel. And what do we have there? Completing this on page 5, you'll agree with me that we just have the integral from 2 up to 4 of du as follows. Page 5, just finishing this off. Let me bring it up here. So that's the one we have. Right, so that's page 5. Now what are we saying? We are saying what we have is the integral from 2 up to 4 of du. You agree with me, there's a 1 here. I've explained last time that this is just u, and we're integrating from 2 up to 4. And what is this? 4, put 4 there and put 2 and subtract. Our final solution is 2. All right, this is how you go about this. Tell me what you think about it. Your feedback remains very important to us. All right, I'll see you in the next one.